Today, we will introduce a high-affinity peptide targeting calprotectin. As we all know, common inflammatory diseases such as ulcerative colitis and Crohn's disease can be diagnosed or monitored non-invasively using the biomarker calprotectin. However, current quantitative tests for calprotectin are antibody-based, and the binding epitopes of these antibodies lack structural features. Additionally, it is unclear whether the antibodies detect calprotectin dimers, tetramers, or both. In this regard, the diagnostics company Biolman has developed a peptide-based calprotectin ligand that offers advantages such as uniform chemical composition, thermal stability, site-specific immobilization, high purity, low cost, and chemical synthesis. Inflammatory bowel diseases, or IBD, including Crohn's disease and ulcerative colitis, are characterized by chronic remittent episodes of inflammation in and beyond the GI tract that afflict individuals with substantial morbidity. Since the identification and characterization of calprotectin in the 1980s, fecal calprotectin emerged as a non-invasive biomarker that discriminates between inflammatory and non-inflammatory diseases of the gut and portrays the disease course of human IBD. Calprotectin is expressed as a heterodimeric protein, MRP8/MRP14 or S100A8/S100A9 in neutrophils and can reach up to 50% of the soluble protein content in the cytoplasm. During intestinal inflammation, neutrophils migrate to the intestinal mucosa and release calprotectin into the lumen of the intestine, where high calcium ion concentrations are likely to lead to a formation of a tetrameric structure 3. The quantity of the marker calprotectin detected in feces shows a good correlation with endoscopic and histological data and indicates the severity of IBD-1. In healthy adults, median levels of fecal calprotectin are 10 to 34 micrograms per gram. Values between 80 to 160 micrograms per gram can represent a mild organic disease or inflammation. In calprotectin above 160 micrograms per gram is highly indicative of active inflammation in the gut, wherein the values for the categorizations vary slightly in literature. As such, the marker is broadly used in the diagnosis of IBD and to monitor disease activity, respond to therapy, and disease reoccurrence. Calprotectin can also be elevated in blood and may be used for monitoring other inflammatory diseases such as rheumatoid arthritis, cystic fibrosis, acute coronary syndrome, or sepsis. Quantification of specific oligomeric states or metabolic products of calprotectin, as is observed in blood, might offer additional value for the diagnosis of diseases. Calprotectin is detected and quantified by assays that depend on antibodies as affinity reagents, such as ELISA, lateral flow assays LFA, chemiluminescence assays CLIA, and turbidimetric assays. While the mono or polyclonal antibodies used in such assays allow for sensitive and quantitative detection of calprotectin, side-by-side comparisons of immunoassays differ in reported calprotectin concentrations up to 5-fold. The observed variations may stem from heterogeneous standardization across assays from different providers, but are likely also caused by general limitations of antibodies, such as protein heterogeneity, interbatch variations, temperature-induced denaturation, and challenges in site-selective antibody immobilization. Furthermore, calprotectin can occur as a dimer or tetramer depending on the sample type and treatment, and some antibodies recognize the different species to different extents. Binding studies with various forms of calprotectin or epitope mapping by phage display have shed light on the binding sites of some calprotectin antibodies, but none have categorized the structure of the antibody-antigen complex. Thus, many of the commercially available assays cannot specify whether calprotectin is detected as a dimer, tetramer, or both, which may be one of the main sources of variability between assay manufacturers. In this study, they developed a calprotectin LFA based on peptide affinity reagents. They reasoned that peptides should offer advantages such as homogeneous product due to chemical synthesis, high stability for a prolonged shelf life, site-directed immobilization, and low batch-to-batch variation. While antibodies are usually chosen as affinity reagents in diagnostic assays due to their low nanomolar or picomolar binding affinities, they speculated that such high affinities would not be needed due to the relatively high concentration of calprotectin in patient samples. Peptides binding to targets of interest can be efficiently developed with in vitro evolution methods, such as phage display and mRNA display, and typically display nanomolar affinities, which would be sufficiently strong for quantifying the typically high nanomolar calprotectin concentrations. Herein, they have screened the largest ever reported peptide phage display library, comprising over 100 billion different peptides and isolated nanomolar binders to calprotectin. We characterized the binding epitope of the peptides by solving an X-ray structure of the calprotectin peptide, and found that peptides bind exclusively to tetrameric calprotectin and thus a defined species of the biomarker. Overall, their work shows that peptides are suitable for the development of sensitive LFAs amenable to the quantification of calprotectin in complex biological samples. With this idea, Christian Gerhold, CTO of the diagnostics company Bielmann, worked with a group of Professor Christian Heines at EPFL to develop human calprotectin ligands based on peptides. From a library of more than 500 billion different peptides, Cristina Diaz-Perlas, a postdoc in Heines's group, isolated several binders of calprotectin and showed that peptides are suited for calprotectin quantification in simplified lateral flow assays. The best peptide had a dissociation constant of 26 nanomolar, a measure of how tightly it binds to calprotectin, making it a good candidate for diagnostic tests. The peptide not only binds to a large surface region of calprotectin, but also to a specific form of calprotectin that is the relevant species in patient samples. Under the guidance of Benjamin Ricken at Bielmann, the peptide was finally tested in professionally assembled lateral flow cassettes and found that it was suited for accurate detection and quantification of calprotectin. In a proof of concept study, this setup was used to quantify the concentration of calprotectin in serum obtained from patient blood samples.